more about all this at the end of the video, but right now let's get to the video. This is a summary of 3 preceding videos. Quick summary. Excuse me. Pascal's triangle can be constructed as we see here. A 1 here, a 1 and a 1 here, and then in every new row, the number in a given block is equal to the sum of the numbers in the 2 blocks above it. So we have here stack starting with 6, 5, 4, 3, 5, 4, 3, 2, and 1 blocks. And stacked as blocks would be stacked if we don't want them to topple. So we pretty much see the pattern here. And if we don't see the pattern, then probably you want to go back to the earlier video. The next few rows, we don't bother drawing the blocks, but we understand that they could be there. So the next row after the last row of blocks here is 1, 5, 10, 10, 5, 1. We get the row below that. The 1 is going to still be a 1 here. The 1 and the 5 give us 6. 5 and 10 give us 15. 10 and 10 give us 20. 10 and 5 give us 15, etc. So we complete rows down through the row that starts with 1 and 7. The rows are numbered. Row 0, row 1, row 2, row 3, row 4, row 5. We start numbering the rows with 0. We number the positions within the row. If these are blocks, we're numbering the blocks, but we start by numbering with 0. We don't make the easy mistake of starting with 1, or if we do, we're going to get something wrong. So we have to remember to always start with 0 in counting positions or in counting rows. Okay, so we have position 0, position 1, position 2, position 3, 4, 5, 6, 7. Okay. Now, it's obvious that we can continue this as long as we want to. So we can make this table as big as we like. Generally, you want to be able to do this up to, let's say, row 10, which would make, of course, 11 rows. And then you would have very handy reference. Why is this handy? Well, let's consider. C of 6, 4 is what? Well, it's 6 factorial over 6 minus 4 factorial times 4 factorial. We write that out. We write it out again. We reduce everything, and we find that C of 6, 4 is 15. What's the meaning of C of 6, 4? It's the number of ways of choosing 4 things out of a group of 6 without regard for order. That's a very common quantity that we're going to get when we start thinking about counting things. Okay, so when we choose 4 things out of 6 without replacement, without regard for order, C of 6, 4 is a number of ways it can happen, and C of 6, 4 coincidentally appears to occur in row 6, position 4. Row 0, 1, 2, 3, 4, 5, 6, position 0, 1, 2, 3, 4. In general, C of NR occurs in row N at position R. So if we wanted C of 7, 5, we'd come down to the N equals 7 row and count over 0, 1, 2, 3, 4, 5, it's 21. Now we apply that to one example, and we're going to ask how many outcomes of 6 coin flips give us exactly 3 heads? Well, 6 coin flips, 3 heads. Let's see. Let's just represent the coin flips by numbers, or by either an H or a T in each of 6 blocks. How many ways can we fill in 3 heads? And then, of course, we're getting exactly 3 heads, so there have to be 3 tails. How many ways are there that we could fill in 3 heads and 3 tails in these blocks? Where this block, let's say, represents the 1st, 2nd, 3rd, 4th, 5th, 6th flip. Each block representing one of the flips. Okay? Well, there are exactly 20 ways to do that, because the number of ways to fill in 3 heads, exactly 3 heads, and then the resulting 3 tails is the same as the number of ways of choosing 3 of the 6 positions in which to put the 3 heads. So we're choosing 3 positions out of 6. Choosing 3 positions out of 6 can be done, and without regard for order. We don't care which head comes first, but choosing 3 heads out of 6, there's 3 positions out of 6 in which to put the heads, understanding, of course, that we're going to put tails in the remaining position. We see there are C of 6 3 ways to do that. C of 6 3 is what? Well, we could use the formula, and if we're using much bigger numbers, we probably want to use the formula. We don't want a huge Pascal's triangle. It wouldn't be very efficient. But if we have at least the n equals 7 row of Pascal's triangle, we can count over 1, 0, 1. See, I started with 1. You got to be careful because there's a 1 there, right? It's position 0, 1, 2, 3. 35. Nope, I'm sorry. We're in the n equals 6 row. It's 6 heads. I'm sorry. Okay, so we go to row 6. Row 0, 1, 2, 3, 4, 5, 6. And position 0, 1, 2, 3. And we find that the number is 20. C of 6 3 is 20. So there are 20 ways in which we could get 3 heads. We could list them. Heads, heads, heads here, and then rest tails. Or here, here, and here. 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 Now, to do all that, I think you get 20. Okay. The other thing we see, just a little bonus, if we add the numbers in the n equals 6 row, what do we get? Well, we add the numbers, we get 64. What's it mean? Okay, well, this number tells us the ways we can get 0 head. This is the number of ways we can get 1. This is the number of ways we can get 2, 3, 4, 5, and 6 heads. So that when we add these numbers, we're adding the number of ways we get 0 or 1 or 2 or 3 or 4 or 5 or 6 heads. Well, when we flip 6 coins, we're going to get one of those. So if we add the number of ways each of those things can happen, we get all possibilities, the number of possible outcomes of flipping 6 coins. And of course, we can verify that. We can draw a tree. Now, I can't draw the whole tree. Don't have enough room on the board. But if we start the tree, we got heads or tails in the first flip. Then on the second flip, we've got heads or tails. And of course, that we got heads or tails with the heads of the first flip, or we can have heads or tails after tails on the first flip. Okay, so we have 2 possibilities for the first flip. We have double that, or 4 possibilities for the second. If we go to a third, we're going to double that. We're going to get 8. And then we double that 3 more times. We get 16, 32, 64. 64 ways to get, to 64 possible outcomes on flipping 6 coins. We can generalize. We can say that the sum of row n is the number of possible outcomes if we flip n coins. Now you can ponder that. You can read, you can look at the preceding 3 videos and see if there's anything here you don't understand. You can find it explained a little more slowly and in a little more detail and constructed step by step in those 3 videos. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphyd.vhcc.edu/vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics, up through multivariable vector calculus and introductory ordinary differential equations.